Good morning, everybody.
Good morning.
Good morning, sir.
Good morning, sir.
Okay, good morning. So, so far, we have learned, at least for the case of a spring system, when we have a number of springs, together, and some boundary conditions are given, and then, so something like this, and then you can find out the different things which are unknown, right? So either force is given, for example, in this case, if the force is given, then you find out the U. Here, for example, you can also find out what are the reaction forces. Okay, so this is a structural system. Yeah, springs or equivalent, we can also may have a bar. Basically, there are two kinds of bar, for varying area of cross section, right? Something like could be there, which is connected, and something like this. Also, it can be like that, right? So this spring and this bar is equivalent, and so on. So even if this is given, you can approach this problem as this problem after finding out the equivalent stiffness, the stiffness or spring constant, and accordingly you can go ahead with that. You can solve it. Okay, now this problem is not only, this finite analysis is not just for a structural system. You can also use for different problems as well. Yeah. So let us say electrical system, for example, right? Electrical system. Although we will denote this resistance now, right? So earlier it used to be a spring, now it is a resistance. And electrical system could be something like this, right? You have any combination, it could be something like this, right? And you will have something given. Let us say this earthing here. Then you have some current which is coming here, right? It could be some voltage is given, some volts here, right? So all kind of things will be there. There's a current which is going out, so I1, I2, this kind of system. And what we have to find out is what is the potential, basically. So what you are doing here, the variable, which all variables you have. In this case also, if you see, you have the nodes, right? These are the nodes, right? Okay, and then you have elements. So these are the elements. So you can, so element 1, 2, 3, 4, 5, 6 element, for example. And you can do the analysis, network analysis, using the finite element analysis. Okay, so finite element method you can use to find out missing things. And what is the missing things? Here, electrical system, two things are important. One is the voltage, or you could say potential. And then another is I, is a current, right? And how do you formulate this problem? So let us say you have electrical element, the resistance R is given here. There are two nodes, node 1 and node 2. Excuse me. So this are, let's say node 1 and 2 you have. Okay. Now, if you look at the definition, as we considered earlier. So it has nodal variables are what? Nodal variables are, we have in this case we have V1 and V2. Right? This is a potential at point 1, potential at point 2, and then there will be a current which will be coming to this point. So we call I1, and the current which is coming to point 2 is I2. Yeah. And then there's a relationship among these. You can directly write the relationship also, or you can also have same kind of define the stiffness in this case the same way as you did earlier. And what we did earlier, we said if you okay, so in this case again, before we go further, we have to understand what is U here, what is F here, and U in this case is the nodal variables, which is V1 and V2, means potential, right? Is the U displacement, F here is the currents. So we have I1 and I2. Remember, currents here are into the system. This is into the system. Okay, it's not that it will come from here, it will go from there. So that means current here will be positive, here it will be negative because it's leaving the system. So but positive thing is any current which is flowing to the resistance will be positive. Hence we have drawn like this. So in this sense, the force vector will look like I1 and I2. The displacement vector will look like V1 and V2. Yeah, like this. Now we have to find out K. What is K then? And K, as you know, in order that the K fits displacement, K we want 2 by 2. So K will be K11, K12, K21, K22. Right? Okay. Now, now we have to find out the value of K11, right? And how will you find out? Okay, you can do like this. K11 is when you fix the node 2 and apply displacement, unit displacement, and measure the force. The force which is measured will be the stiffness, K11. And in this case, what we mean by a force is, in this case, force means current. In this case, displacement means voltage, right? So we are fixing V2, we are making it equal to 0. So what we are saying that we have R here, and then we are making V2 equal to 0, right? Okay, and then what are we doing? Then we are making V1 equal to 1, right? V1 equal to 1. So these are displacements. V1 and V2 are like displacements. So by definition, we are fixing the other end. Fixing means the displacement we will make equal to 0, but displacement here means the voltage will be 0 at this end, and voltage will be 1 at this end, right? And then the force we measure here will be the K11, because this is 0.1, right? So 1, 2 is 0.1. So what will be the force? Force here is current, means I1. What will be the I1? What is the current which should go here? So we can find out. So K11 will be equal to what? 1, like V2 minus V1 over R, right? Potential difference, right? So current will flow direction we want this way, and hence V1 minus V2 divided by R. But we know that V2 equal to 1, V1 equal to 0 over R. That means 1 over R. So K11 equal to 1 over R, right? Now, we have to find out K12. Now, in the same situation, when you have a current flowing here, which is equal to 1 over R. Potential here, V1 equal to 1 and V2 equal to 0, right? If that is the case, then whatever currents come here has to go out. Automatically we'll see here, we will have I2 in this case will be equal to 1 over R. But going out, if I2 is going out this way, actually, so in fact, I should write I2 equal to minus, we should not write this. We just see that current which is going out is 1 over R, and hence K12 will be K12 equal to minus 1 over R. Why? Because this is going out of the system. That's why minus is coming. So K12 equal to 1 over R. And similarly, you can analysis for the other end. So you fix this end and you apply a current here, yeah, and this will be 0, V1 equal to 0, V2 equal to 1, and you do analysis, you will get the same value. Basically, what I mean to say is you get like this, 1 over R, 1 minus 1 minus 1, 1. Yeah. So basically, your what is the equation you get? You get 1 over R, 1 minus 1 minus 1, 1. Then you have here V1, V2 is equal to I1, I2. This equation you get. Now you can use this to solve any kind of network now. Yeah, this becomes a very powerful like a statement. Yeah, so you can now assemble the big system. You can use, for example, right? So any complicated circuits, star delta connection, for example, right? So you can use any kind of thing. Yeah. So okay. So if you have this kind of thing, for example, right? So then you can let us say it's like this, and so on. So then you can easily write, right? Let's say this is R1, this is R2, this is R3, R4, R5, R6, R7. Yeah, then you have nodes. You can have the voltages here. So what is given, and so what you see here, the forces are given, like currents. So there may be some currents coming here. So if you know what is the current, in fact, you can also make general purpose. You can make it here. You can number it. For example, let's number it first. So this 1, 2, let's say call 3. This is 4, right? And then this is 5. This is 6. Let us say. Okay. Okay. Now here, what you see in this case, you can give the value here. I1 is given, right? So let's call it I0. Yeah. So I1 equal to I0, which is given here. So this is like a force is given. This is like a force, right? If you have like this, that means a force is given. And what is the force given? I1 equal to I0, because the current is coming. The current is being supplied. Here, what do we know? Do we know the voltage? We don't know. We have to find out. Do we know the current? Yes, there is no current coming here, right? So here the I6 will be equal to 0. So force, if it is not applied, that implies it is 0, right? Okay. Okay. So this is and so on. You can solve accordingly. Yeah. So any question, guys, on this one? This could be, let us say, 6 volt here given, right? So there's a cell here and 6 volt, let's say, given. So then you can say V4 equal to 6. Yeah, because you have fixed potential here, right? Because of this battery. So that makes it the V4 equal to 6. You will write it. Yeah. Here this is earthing is there. So you will be V3 equal to 0, right? Others we don't know. So here current is given, and the voltage we don't know. Here also current is given, a current equal to 0, right? This is the net current. What is the current coming to the system, right? Here it will be net will be 0 because whatever comes will be leaving, right? So it will be 0. Here also
Sir,
it will
here
be
the
0.
hello, sir.
Yeah.
Here the stiffness matrix will be 6 by 6, right?
Here the stiffness matrix will be based on number of nodes. So here how many number of nodes? 6. So 6 by 6, correct. Yes.
Thank you.
Yeah. Okay. So for every element, you have to find the stiffness matrix. So for this one, it will be 1 over R3, 1 minus 1 minus 1, 1.
So
For
like last time, we can superpose all these things, right?
Yeah. So similarly, you have to do here. So for this will be 1 over R5, 1 minus 1 minus 1, 1. This will be for this. And then you have to assemble the way you did for others. Yeah. Any question? Okay. Now, similarly, any other like any other problem, and in this case, in fact, in a spring case also, you can directly write the equation from there. Also, you can do. So, like let's say in a spring, now you directly write the equation. You don't need to actually fix one and give the unit displacement and measure and all kind of things. Those are to understand what the physical implication is. However, we can just given the equation also we can compose. So for a spring, for example, coming back to that, so you know that this is U1, this is U2, this is K. So what is the equation? We know that the force will relate to, so whatever, let's say we have force like this. So our see it. So let's call this one as F1 and F2, right? Okay. Now this is under tension, right? So how will you write the equation? So if you see here the if it is under tension, we can just simply write F1 will be equal to K, then it will be U2 minus U1, right? Okay. So and will be equal to F2, right? Yeah. So our equation is like this one. Now, if you look at let's this we call it since we want in the same direction, then what happens here? If instead of we write F1, so instead of this we say F1 here, right? And this is F2 here. So what we want to do is we have F1 here and we have F2 here, the same direction, right? Okay, and then you have U1 and you have U2. Capital F1 I wrote. So F1 is nothing but minus F1 and F2 is nothing equal to F2 only, right? Rest remains the same. So the first equation becomes what? First equation becomes this is F1 equal to minus this big F1, right? So we write minus F1 equal to K U2 minus U1, right? That makes it what? Equal to, that tells us sorry guys. So here F1 equal to K U2 minus U1, and in that case what happens? You can write it as is equal to, this one is equal to K U1 minus U2 equal to F1, right? So we got the equation number 1. Equation number 2 will be K U2 minus U1 equal to F2. And F2 and this F2 both are same. So equation number 2 is K U1 minus U2 equal to F2. Now from equation 1 and 2, simply you can write, it will be like K minus K minus K, K, and U1 U2 equal to F1 F2. So it is the same thing. Directly from equation also we are writing the same thing. Yeah. In case of resistance also you can do the same thing. No, so we fixed one thing, we stretched, and we given a unit displacement, found out what the force. All those are for understanding. It is something like if you are in the lab and you have to find out the stiffness, how will you measure it? Here, what we need to do is you just know the equation. Actually, you know the mathematics. From mathematics also you can derive it. And similarly for the resistance, you are talking about the electrical system. This is the same thing. What you have is like this, right? So you have a current I1, and this is a current, this is I2, and you have V1 and V2. And what is the relation? You know that I1, whatever goes inside has to leave, and you know that I1 plus I2 equal to 0, or simply I1 equal to minus I2, right? Second thing is what you know is V1 minus V2 over R. So this is R equal to I1. So I1 equal to V1 minus V2 over R, right? Which is equal to minus I2, because I1 equal to minus I2, hence this is minus I2. So this equation, this gives you two equations, right? This gives you two equations. One equation is this, the other equation is this one. And this you can rearrange, right? We have I1 equal to V1 minus V2 over R equal to minus I2. And this equation simply gives us like this, V1 minus V2 over R equal to I1, right? And then we have V2 minus V1 over R equal to I2, right? See here, minus you becomes minus here, becomes plus here, hence V2 first, right? And both together will give you this equation, right? 1 over R minus 1 over R minus 1 over R, 1 over R multiplied by V1 V2 equal to I1 I2, right? So mathematically also you can do it, not necessarily you have to do the other way. That was only to make you understand what is the meaning of that. Okay. Similarly, some other heat transfer problem you can work on, right? Heat transfer problem. And what happens, like you know that if there is a bar and it has a temperature T1 and T2, then there is the heat transfer or heat conduction, basically heat conduction, right? Okay. And then there is a Q which flows, right? Q is here there's an energy which is coming into the system. This is and this will conduct. And what is the equation? Q will be equal to, Q is proportional to the T1 minus T2, right? Multiplied by area divided by L, and this is K, right? And this K is known as thermal conductivity, right? Yes. So this also you can use it. So this Q will be equal to K A over L and T1 minus T2. Similar kind of equation you can write. So we will have here Q1 and Q2. So Q1, this is Q2. Both are like energy flowing into the system. This is the heat transfer per unit area per unit time, right? So this is this one is actually this tells you how much energy is being transferred. Yeah. Okay. Now this is this Q1 and Q2 both are positive when they are the energy is being transferred or heat is being transferred to the system, right? So hence it is like this one. So you can write the equation same as Q1 plus Q2 equal to 0, because whatever the energy coming has to leave, because there is no heat transfer from this surface, okay? Only from this surface only. So if the heat if this is Q1 is coming here, and the same amount of heat has to leave, right? Okay. Why? Because it's a steady state problem. So this is a steady state. Remember, in this course, we are looking at the steady state solutions only. Okay, so heat transfer, it could be transient also, meaning that with time it will change. But this kind of problem we are not looking at, right? We are looking at the steady state problems only. Yeah. Okay. For if you want the transient kind of problem, for that alone, finite element alone will not give you answer. For that you have to need the finite difference and all. Okay, so that is different course. Okay, so any equation which has time dependent things, we will not work here. Okay, so we want only those problems which is in a steady state, so that we can find out what is the values. So we have a steady state heat transfer, hence what happens, temperature here and here will be constant. Basically here also it will not varying with time, and also there is no heat transfer from here, so that temperature is not varying anything. Whatever heat coming into the system has to also leave, hence Q1 plus Q2 equal to 0, right? Okay, and now also Q1 is given by T1 minus T2, right, multiplied by Ka over L, right, which is equal to minus Q2, because this gives you Q1 equal to minus Q2. So you can rearrange it the way you did earlier, and you can find immediately that the value will be Ka over L, or simply we can write K over L as a common thing. So Ka over L, 1 minus 1 minus 1, 1. And here, what is the displacement here? Displacement will be, so will be what? This is the displacement appearing here, right? So this is the displacement which is being multiplied, and these are the force, right? This is like a force term. Okay, so this is the displacement, because change in displacement, like in the spring, what happens? Change in the displacement will dictate what the value of force is. Here the change in temperature is going to dictate what is the heat transfer, right? So here displacement will be temperature. So you got T1 T2 is equal to, then you have Q1 Q2, right? Okay, and you can solve it now. Yeah, so you may have a system of bar, like the system could be like anything. Let us say your system is something like this. Something like this, where somewhere temperature is given. So let's say there are node number 1, 2, 3, 4, 5, right? So T5 you can make it equal to 0 for example, right? Somewhere Q is coming, so we can tell here this Q3 equal to 5 joule per second, something like that, right? Okay, and then based on that you can find out how the temperature will be at other places. You can find out, yeah, just based on that. There is no Q coming here, so Q4 will be 0. Q5 we don't know. Here, like if temperature is given, that means you are fixing temperature. That means there has to be somewhere a sink, basically, right? A sink or some temperature you cannot tell that Q is equal to 0 and temperature equal to 0. Both you cannot prescribe. So this is only possible that if some kind of source or sink has to be there in this case, yeah, so that it can maintain the temperature, right? So any confusion, you should go back to the definition in terms of force and displacements. So in this case, force means Q, right? And displacement means temperature. Yeah, like when your temperature, if you have temperature you are fixing, then force you cannot fix. It means the displacement, temperature, the displacement you are fixing, force you cannot fix. The temperature you are fixing, the Q cannot fix. Q will be whatever is needed to make that temperature. That means either there will be a sink or source, whatever has to be there, and it will automatically, you will know by solving the problem, you will know that. So any questions so far, guys? Okay. Now there could be many other kinds of problem. Okay, so even fluid mechanics problem you can solve. Okay, and fluid mechanics, you can have a pipe, for example, through which there will be a so there will be a Q, right? You say Q, flow rate, right? This is a mass transfer. This is the any fluid volume per unit time. That's Q is the volume of fluid per unit time. That's Q is, right? And Q is given by, like in case of it's called Poiseuille equation. And this Q, anybody knows what is the value of that? Minus pi R4 dP over dx. So equation we can write later on over 8 mu. Is that correct? Anybody remembers that?
Yes, sir, it is correct, sir.
Yeah, okay. So Poiseuille equation tells you that how the fluid will flow through a circular pipe, okay, and where this is a pressure gradient, R is the radius of this pipe, mu is a viscosity, right? So or this one, what you get in from here is actually dP over dx term is there, right? So that means if let us say you have 2 points 1 and 2, right? So you can equal to it says pressure here has to be greater than this one, so that the flow can be from point 1 to point 2. So this will be simply pi R4 divided by 8 mu, and then it will be P1 minus P2 over L, right? So if the length is L, yeah, so this is how the equation will be. Or simply this is a constant, together there will be a constant, and then you have P1 minus P2.
Sir, I think
right?
it is P2 minus P1. Sir. There is a negative sign.
No. So this is a negative, no? Negative sign here, and dP over dx. The dP over dx means
P2 minus P1 dP is.
No.
Sir, it's fine.
Yeah, this is correct. Now you think in this term, no? Pressure here has to be larger than this one. Then flow is positive, because this the flow will be from higher pressure to lower pressure, and hence P1 minus P2 will make you a positive Q, and hence I'm not writing any minus here. We have minus here, minus dP over dx equal to P1 minus P2 over L. Everybody agrees?
Now I understood, sir. Thank you, sir.
Yeah, okay. So similarly, the way we did earlier, we can do the same thing here. So we can write Q1, you write Q2, right? So there, this is point 1, this is point 2. So we have pressure here P1, pressure here P2. So what we have, this pressure is like our displacement, right? It is like a displacement, and this Q1 and Q2 is like as a force. Yeah, okay. And you can write the equation. Equation is Q1 is equal to pi R4 over mu 8 mu L, right? This will be P1 minus P2 is equal to minus Q2, right? Okay, and then if you rearrange, what do you get? You get this pi R4 over 8 mu L, and then you have then what do you get? You get 1 minus 1 minus 1 1, right? And then you get P1 P2 is equal to Q1 Q2. This is the equation. Yeah, so this is the stiffness matrix, and this is a displacement vector, and this is the force vector. Yeah, and you can assemble now, so any kind of pipe, let us say you are going to analyze, so in a building there will be pipe going like this. Yeah, okay. Now we are talking about the simple pipe where the height is not varying, so there is also physics come into play. Yeah, so here equation like when you changing the height, the pressure will change and all. So as long as you are correct with the let us say all of them has same height, so they are like horizontal piping. Okay, so not to complicate, because of the gravity also there will be things will be changing, but we want to make such a way that all these are horizontal only, right? So this kind of piping system we have. Yeah, so let us say we have like this kind of pipe going, let us say. Okay, and then what happens here? We can either have a pressure, so we can, let us say, fix it like this. Yeah, so there is an inlet, there is an outlet, let us say, so now you can find out. So you have different points, nodes. So node number 1 2 3 4, right? So this is 1 2 3 4 5 6 7, let us say. And of course this is a too simple, very simple basically, because of the corner also there will be a change in the flow and all, but we are discounting that. We are just assuming it will depend on the pressure. So whatever the pressure is, based on that it will work. So if the Q is given, for example, here there will be 0.1, so Q1 is given. Q1 is given. Similarly, there may be Q2 which may be given, right? Then there may be somewhere pressure which is given, right? So there may be some open here that makes it atmospheric pressure, for example, right? So there will be some pressure as well which is given. Based on that, you can find out the Q and all, right? So you solve. This is just one example, a very simple example, but you can solve using that. Yeah, for different elements. You have element number 1 2 3 4 5 6 7 8, and you can do it. Any question, guys?
Sir, sir, as we are dealing in all these problems in one direction only, so like in horizontal direction or in one direction only, and if we will go further with two directions like x and y direction, then do we have to inculcate both the direction in the same matrix, or we will have to develop two different matrices for the two directions?
Okay. It depends on the problem. Right now, see, here it does not matter because this is actually it is not one-dimensional actually. If you see here, this pipe could be in 3D, no problem. Why? Because here the variables are scalar, right? The pressure and flow, those are actually scalar quantities. As far as what is this one? Flow. This gives you volume per unit time, right? Volume per unit time. That's
Yes,
it.
sir.
Here, no need to tell which direction it is flowing. It is just like net, whatever coming to this point. Pressure is again, pressure in this case, here also, this is a scalar only, scalar sense. Yeah, so whatever the pressure is, it will work either this direction, or in all directions. So here there is no problem, so it will work. Okay, so like although, I mean, here we see the two-dimensional thing automatically. In a resistance also, if you see in case of resistance, like electrical system, it can be 3D also, right? 3D system, 3D system meaning that their connection is 3D, right? So it can be like this one. But individual elements, those are actually will not, doesn't matter. Say like this thing only, let us say I rotate it. Whatever was north becomes east. Will it matter? It will not matter. The value will be the same, right? It will not depend on the direction. However, what you are saying, in case the variables are vector, things will be different. So let's say we are talking about the bars. Now, when you are talking about the plates, things will be different. Then you will have two displacement, U1 and U2. And this we will learn later on. Right now, we will concentrate on 1D only. So U1, U2, U3, U4, U5, U6, U7, U8. There will be 8 degrees of freedom per element. So we will get that. But this is, we will do at the end of, towards the end of the semester. So we have long way to go. So this is not that easy. Yeah, so first we go just looking at the direct method. For this, we will need some kind of equation. From there, we will simplify, we will find out what will be the stiffness matrix. Yeah, so we will be doing all those things. But right now, all this problem we are talking about, whether heat transfer problem is scalar type, right? It's a scalar. The variables are scalar, like temperature in that case. Here, voltage, which is a scalar quantity. Then you have fluid flow, pressure, a scalar quantity. Yeah, I mean, a scalar quantity in a sense that fluid will depend on the pressure, and pressure for the fluid, pressure is a scalar quantity, right?
Yes, sir.
Pressure will be all directions.
Yes, sir.
Yeah. So does it answer your question?
Yes, sir. Yes.
Okay. Any other question, guys? Yeah, okay. Now, Shubham, it is good that you asked that question, because next class we will be working on what is called truss. Okay, and truss, what happens? So we have just learned today. I learned, like we have been learning, if there is a bar, and then if you have a linear system, as you said, if you have like this kind of system, then we can solve it given this, right? Then we can fix 1 point or fix 2 points, then apply a force here and find out what is the displacement. So let's say you call it node 1, 2, 3, and 4, and what is given is U2, not U2, but it could be anything. F2 is given, and then sorry, I think he said, yeah. So F3 is given, and U2 we have to find out, right? So this kind of thing we have done, where these individual elements are different sizes. Based on that, we will find out what is the stiffness matrix and all. Now, this is really 1D problem, right? And now, based on that question only, now what happens when we change the direction? Meaning that, what about we have a scenario where we have a problem something like this? Right? And like this. Then what happens? How will you solve it? There is one bar here, the another bar, and this is fixed, and you have a force hanging here. Then how to solve it? Now, this is what is known as truss problem. And as you already, you should have idea already that in that case, we are going to have, so let's say we have like this. If you draw the Freeway diagram, then what do you see? This is F here, right? So you will see something like this. So you will have force here, there will be force here, right? So you will get F1, this is F2, F3, F4, right? And here F5, F6. F6 is given, which is equal to minus F, right? All these are reaction forces. Displacements, accordingly, displacements will be, the displacement will be accordingly. Doesn't matter, we can write F1 upward also, or this way. Anyway, this is for just showing. So there you see the discrepancy. I said Y direction first and then X direction, but here X first, and so doesn't matter, as long as you know which direction is which degree of freedom, so you are fine. So here accordingly it will be U. In this case, in this problem, U1 equal to 0 and U2 equal to 0, right? Here also U3 equal to 0, U4 equal to 0. Here we don't know, so U5 equal to what, U6 equal to what. Now you see, earlier one node has to have only 1 degree of freedom. Now one node has 2 degrees of freedom now. We have, because this is how the displacement defined. Whenever say displacement is not the absolute one, and we are not interested in that. We have to find out in X direction what is the displacement, in Y direction what is the displacement, and it makes sense because all the directions are independent, meaning that sum of forces in X direction is equal to 0, for example. So in that direction it is self-sufficient basically, right? Even if you don't consider the other direction, this will still, it will be valid, although all the direction will be taken together as in, when you say summation of the moment has to be zeros, automatically both of them are also related, otherwise they are independent too. Okay, so now so here simply what we get from here, that we need to somehow from this linear system to 2D system, or where so far we studied that 1 degree of freedom per node is not sufficient as far as the structural problems are concerned. For other kind of problem like electrical, still it will be the same as earlier, because there for electricity, you know that still the current is coming regardless of from which direction the current is coming. It doesn't matter. Finally, what it bothers about, what is the current reaching here, that's it. Whether the wire coming from this side or this side or this side, all are electricity only, right? But not in case of structures, because force in this direction is different from force in this direction, and it will change, right? You apply a force in this direction, it will move this way. You apply a force in this direction, it will move upwards, right? But unlike in the electrical system, if your wire is coming from this side or this side or that side, all effect will be the same. Yeah, so that's the difference. So next class we will be concentrating on the what we call the the truss. Okay, how to formulate the finite element analysis for the truss, so that any complicated truss even like something like this, let us say you have this kind of problem, right? Breeze or something, right? You have like this, and then how to, you can analyze it very nicely. There may be some forces here or here, like this, and you can find out what is the displacement. Okay, so any question?
No, sir.
Yeah, okay. Okay, guys, then see you tomorrow. If there is no question, so we will study truss tomorrow. Okay, thank you.
Sir.
Yeah.
Yes, sir. So I was traveling yesterday. So did we have a tutorial session yesterday?
Yes.
Sir, could you please brief me what happened?
So I will upload the video, okay? So you can watch that, okay?
Okay, sir.
So I have recorded that, so I will upload it.
Okay, sir. Thank you.
Okay. Yeah. Okay, guys. See you tomorrow then.
Thank you, sir.
Thank you, sir.
Thank you, sir.